Good afternoon to all. The session will start within few minutes. Good afternoon, everyone. Before we start the session, I request all participants to please remain muted and keep their cameras turned off. I warmly welcome all the participants to the third day of the one-week FDP on building knowledge-driven autonomous systems, generative AI, agentic AI, and edge AI. I hope you found the previous sessions informative and engaging. Today's session takes us deeper into the design and development of intelligent AI systems that can effectively utilize organizational knowledge and make autonomous decisions. It is my great pleasure and privilege to introduce today's distinguished resource person, Dr. K. Shekhar, professor in the Department of Computer Science and Engineering and head of the Center for University Industry Interaction at Aurora deemed to be University, Hyderabad. Dr. Shekhar completed his BTech in Computer Science and Information Technology in 2004, MTech in Software Engineering in 2010, and earned his PhD in Computer Science and Engineering from JNTUH in 2023. During his academic journey, he had the opportunity to work with prestigious DRDO laboratories, including DRDL CARE and ASL, contributing to various research and project activities. With an impressive career spanning more than 22 years, Dr. Shekhar has made significant contributions in the areas of teaching, research, administration, and industry collaboration. His research interests include artificial intelligence, machine learning, deep learning, data mining, pattern recognition, and natural language processing, which are among the most sought after domains in today's technological landscape. Dr. Shekhar is actively involved in research and is currently guiding several research scholars in advanced areas of computer science. He has authored a book, contributed to a book chapter, published multiple patents, and presented numerous research papers in reputed national and international journals and conferences. His academic excellence has been recognized through several prestigious awards, including the Jyeshtha Acharya Award 2024, Young Scientist Award 2022, Kalpa Acharya Award 2021, Best Academician of the Year Award 2021, and the IEEE Young Professionals Achievement Award 2020. These honors reflect his dedication to academic excellence and innovation. Apart from his research and teaching contributions, he has served in various academic leadership roles such as HOD, Training and Placement Officer, Examination Branch Coordinator, and Certificate Verification Officer. He is also associated with several professional bodies and serves as a reviewer for numerous international journals and conferences. Dr. Shekhar has delivered more than 50 invited talks, guest lectures, FDP sessions, workshops, and webinars across various institutions, inspiring both faculty members and students with his expertise and vision. His commitment to prompting research, innovation, and lifelong learning has made him a highly respected academician and mentor. We are indeed honored to have such an accomplished scholar and researcher among us today. On behalf of Andhra Loyola Institute of Engineering and Technology, extend a warm and heartily welcome to Dr. K. Shekhar, sir.
Thank you, madam. Thank you.
Sir, over to you, sir.
Thank you, madam. Thank you for your vast introduction.
Over to you, sir. Thank you.
Good afternoon, everyone. Nice to have an introduction from the coordinator. So, firstly, let me thank the management of Andhra Loyola Institute of Engineering and Technology for giving me this opportunity, to the management, the coordinators, the head of the department, and my dear friend Pavani madam. So without wasting our time, madam, any problem with the connection?
Yes, sir. It's breaking.
Just a minute. Is it fine, madam, now?
Sir.
I'm getting an echo.
Yes, sir.
Is it okay, madam, now?
Okay, sir.
But I'm getting an echo. Is this fine, madam, now? Yeah. Am I audible, audience?
Yes, sir.
So thank you once again. So let us move on to the session directly without wasting your time. And before starting the session, may I know the target audience, madam? I hope the faculty members, because as of now I can see 55 members, 55 people. So good afternoon all. Good afternoon all the audience.
Good
Just to
afternoon,
check
sir.
how many are active enough. Can you please turn on your videos, everyone, so that the coordinators can take a photo session and for their filing. Okay, fine. Is my screen visible to all? Is my screen visible to all?
No, sir.
No.
Just now is it visible to all?
Yes, sir.
Yeah. Thank you. So today I'm going to deal with topic agentic AI, agentic RAG actually. So it is closely related to agentic AI as well as genetic AI. So let me know how many are aware of RAG, a traditional RAG. RAG stands for Retrieval Augmented Generation. So how many are aware of RAG, traditional RAG? Then we'll move on to what exactly agentic RAG is. Any idea? Faculty members, research scholars? Okay, fine. No, don't worry. So basically, RAG, this is nothing but a retrieval augmented generation accompanied with artificial intelligence and machine learning, because nowadays you're using chat gpt, gemini, all the AI tools where they are auto generating the required information. So whatever the information is required, even nowadays when you are going for research as well, you are getting the plagiarism as well as what is the AI content in it. So it has become a habit and a part of our life that for everything we are using AI. Okay, but how these AI tools are generating this? Whenever you are going for generative AI, generative artificial intelligence, how that information is getting generated, how it is being retrieved. So that information is focused on RAG, so retrieval augmented generation. So basically, let me give a glance, then move on to the slides. So when you go for RAG, basically an end user or an agent will depend on an LLMs, isn't it? So a query is given to the LLM along with whatever either a pattern or a sentence. Okay, so based on that, LLM will generate certain information which is required for us. Okay, so what this LLM will have? LLM will have all the related information. It has millions and trillions of data sources which are embedded to it. Then it will search information from that particular repository. But say for example, whatever the content which I have asked to the LLM, if it is not there in the sources which are embedded in it. Say for example, let me give a small example. The recent version of ChatGPT 5.3, which was introduced in April 23rd this year, 2026. So whenever that LLM was introduced, so it will have entire information or details from various repositories worldwide till April 2023. Sorry, April 23rd, 2026. Okay. Now today's date is 17th, 17th of June. So if I give any other data pertaining to the duration after April 2023, April 23 to till date, it may not give the exact information. It may not give the precise information, isn't it? So what it does, so instead it can't just be like without giving any information as well, because it cannot prove itself as a fool, isn't it? So what LLM does, if it is not having any information available in its repositories, it will give some related information based on the historical transactions or historical searches, whatever the searches the previous persons have done. So you may get a answer or solution to your questionnaire based on some related, but not exactly. But what we expect as an end user, we expect a precise information or an in detailed information, isn't it? Even nowadays, whatever the AI tools are generated, blindly don't believe that it is 100% accurate. So that is the reason even we guide our students and even we use AI tools, but at the same time we analyze that particular content to what extent it is okay for us, and we further modify it. We edit that particular content to our format. Okay, so we can't exactly expect 100% content and directly submit to whatever the faculty member is asking. Okay, so what we do, it directly mimics that particular information as if pretending that it know everything. Okay, so that part you call it as a hallucination. So the LLMs will behave a hallucination. So though it is not aware, it will give some related content. So it cannot be a blank. Okay. Very rarely you find some LLMs or some voice recognition systems saying that I am in a training phase and still lot of thing is to be learned. So please help me in learning. But otherwise, most of the LLMs will not give such responses. They'll give some related information. So what we do is, instead of going for related information, because I'm not happy with 90% or 95%, so I expect 100% accuracy. So for this, the traditional RAG is embedded with the AI and machine learning content. In fact, we'll be going for a database, which you call it as a knowledge base. So that is the reason we have a designing knowledge-driven autonomous AI systems. So what is this designing knowledge-driven autonomous AI systems? We focus on having a knowledge base rather than a database. So database is a generic which depends on multiple sources, but when you are going for knowledge base, it is a related content, the most related content what the user is asking. So they will be maintaining a knowledge base apart from the database. So that knowledge base is used to give the responses to the highest accuracy required. So that exactly you call it as an agentic RAG. Okay. So this is a simple overview of the concept, title justifying the title. So by the end of this presentation, you will be focusing on or able to understand the evolution of Navy R RAG, that is the traditional RAG, to agentic RAG architectures. In-house, you have 4 different versions or variations based on the years started from 2020 to till date. Then you can be able to design a multi-agent RAG systems with specialized retrieval agents. So why we focus on multi-agent RAG systems? Because when you focus on a single agent, we expect in a single step. Okay, so instead of that, I want the sources, I want to be the data or information retrieved from multiple sources. So I need to focus on the multi-agent rather than a single agent. And I also want to focus on the specialized retrieval agents. So what do you mean by specialized retrieval agent? I want the closely related. It's not a generic. Say whenever I'm asking some applications, say for example, if I'm going for a medical diagnosis. So within medical diagnosis, I want to go for a specific disease. Okay. If I want to go for a specific disease, say cancer. So within cancer, again, there are varieties of cancers, isn't it? So likewise, I must not have a generic picture where only from the historical data it searches the information and then gives it. So that is just called an information, but I don't want information. I want knowledge. So how can you differentiate a data, information and knowledge? Data is the one which is already available with us. Say for example, databases or data warehouses. So that you call it as a data. So it can be a rough data, it can be in a structured format, it can be in an unstructured format, it can be in a semi-structured format. And from that particular data, whatever the format it is, if I perform some simple calculations wherein I can get some useful information or useful content. So that I call it as an information. And from that particular data, you may have some hidden patterns where performing some simple calculations may not serve the purpose. So in such situation, you'll be using data mining techniques, you'll be using machine learning techniques, you'll be using RAG architectures, RAG architectures. So finally, you will be getting a knowledge. Okay, a simple analogy, say for example, since we are all in the teaching profession, if generally we do give weekly reports to students, like weekly attendance or fortnight attendance, we call it as, right? So when we are going for a fortnight attendance, you'll be having all the 60 students database along with each and every subject. What is their number of classes attended out of total number of classes held? So likewise, you'll be having all the different percentages in an Excel sheet, right? So that can be termed as the data. Then what would be the information? Information is, say for example, if I want to check how many students are falling less than 75% attendance, or how many students are falling in between 65 to 75. Okay, so like this, I can easily put up a particular condition at the attendance percentage, then divide into 3 categories: greater than 75, which is a safe zone; 65 to 75, which is a you can go with respect to some medical reason and all; less than 65, which is a danger zone. So like that, this particular content what you are generating is called an information. Now further, if I want to go for some information like among that 60 students, how many are expected to get placed by end of their BTech? Okay, so which is not directly available. In fact, I need to focus on their attendance. It's not like the person who is having 90+% attendance is getting placed. So sometimes even less percentage attendance percentage student also may get placed. So it all depends on their attendance, their regularity, their sincereness. Also sometimes depends on their family background. Because if the family members are interested in sending their ward abroad, then he may not turn up for placements. So as a placement officer, I need to focus on all these different criteria. I need to focus on their analytical skills. I need to focus on their technical skills. Okay. I need to focus on their communication skills. So there are many factors which are influencing. So that's the reason we move from a database to data warehouses. Okay. So focusing on the multidimensionality. Now, similarly here also, whenever you are going for rack architectures, we will be focused on the specialized retrieval agents. So I need to focus on the multi-agent rack systems rather than a single agent rack systems. Okay. And then implement autonomous decision-making loops for knowledge retrieval. So why I am going for an autonomous? Because say for example, whatever the information I want to search, if it is not available in the LLM, then the LLM must have a capability of thinking on its own based on the previous occurrences or previous historical data, and then make up a decision or come up with some decision making. So it can go for n number of loops. Loops means it is generating, like you can have a back propagation theorems. So when you go for back propagation based on the error, you will be repeating that particular process until you some threshold value is reached or the error is becoming zero, right? So it must have some knowledge of thinking on its own, which you term it as autonomous decision making for the knowledge retrieval. Then you must also be able to evaluate and optimize rack pipelines using production grade metrics. So in the upcoming slides, we'll be discussing about various pipelines of rack. Then build scalable, observable, and cost-effective agentic rack systems. Now, what do you mean by scalable? So, scalable means it can be extended. Say, for example, I am developing a particular rack system only for say 1 GB of data currently. Okay, but in future, when the new records are coming up, it must also support for a database which is of 1 TB. Okay, so it must be scalable, observable. Each and every content generated must have a proof. Each and every content generated by rack system must be a measurable. Okay, generally any particular functionality will be using certain metrics. We use an accuracy, we use sensitivity, we use specificity, we use an ROC curve area. Okay, we use certain contents of confusion matrix like true positives, true negatives, false positives, false negatives. So like that, precision, recall, there are many metrics where all these are measurable, that is observable. So until and unless you have some measurable content, you cannot give a conclusion of whether a model being built is a success or not. And at the same time, it must be a cost effective. So since I am going for a precise application, I must not go beyond my cost, which is being invested by the organization. So I have to focus on the time complexity, I have to focus on the space complexity, I must also focus on the cost effectiveness, right? And then finally, you will be able to apply advanced patterns, like you have various versions of rack, self rack, corrective rack, multi hop rack, all we'll be discussing at the second half of our session, right? And expecting all the target audience, faculty fraternity, AML engineers and architect, data scientists. So it is useful for each and everyone, because nowadays we are all in a world where we are continuously generating data. We are focusing on multiple architectures. So we expect an application which is suitable for that particular scenario. So agentic RAG will help you in all these different variations. And so first, why there is a need for moving from traditional RAG to agentic RAG? So as already discussed earlier, traditional RAG is simply when an end user is asking particular query, okay, or with respect to a particular prompt. I may also give prompt sometimes. I may not give directly input. I'll be giving prompt like, hi, can you please generate a calendar for me? Okay. Or assuming that you are a cricketer, please give me the different kinds of shots to be played against a particular bowler. So like that, I can come up with different prompt, or sometimes I can come up with a different query, focusing on multidimensionals. So whenever I give that, so what a traditional RAG does is, it focuses on a retrieve, rank, and generate. So whenever a query or particular prompt is being provided to the LLM, it will search its related patterns, whatever there in the information repositories, then it will prioritize the solutions. It will prioritize the solutions or simply rank the solutions, then generate based on the given query, isn't it? But here, whenever it is giving all this information, you will not have any previous interactions. In fact, a traditional RAG will not have any states concept. Okay, and it is given in a single pass. You'll have a single retrieval attempt. Okay, and there is no any justification maintained. There's no any proper reasoning being provided by the traditional RAG because it may or may not appear in that particular information repositories. Then it will have a static strategy, because since I am focusing on only the millions and billions of information available in the current LLM, as I told you. So it clearly focuses on only the data which is available till that LLM was generated, till that LLM was provided. Okay, so beyond that, it will not work out. Okay, in fact, rather than having will not work out, it will give some related answer, because as I told you, no LLM will give a blank answer. Okay, so it will give some related answer. And since I am not focusing on validation, okay, so whatever generated answers cannot be self-checked. So there is no verification done. Okay, and I'm having a limited adaptability. Why I'm having limited adaptability? Because all the data sources are static. The data sources which are available with the LLM are static data sources. They are not dynamic data sources. And I cannot switch to the data sources dynamically until and unless the LLM is correlated with a knowledge base. Okay. So once it is correlated with the knowledge base, then there will be a shift from a traditional RAG to the agentic RAG. Right? And the result of traditional RAG will be hallucinations, as I told you already earlier. So whenever retrieval misses the critical content, then rather than giving a blank solution or a blank answer, it will try to pretend itself that it is having some information with it. Okay, but how does the end user know whether it is a hallucination or the real content being provided? The end user, mostly the data analyst, will check as per their query or as per their prompt being provided. Okay, and then there is a chance of getting incomplete answers, because whenever I am focusing on multifaceted questions, like for example, you can also term it as multi-dimensional query. Okay, say for example, if I ask how many students are having greater than 75% attendance, then immediately I get an answer. But if I ask how many students are having greater than 75% attendance in the current semesters, did not have any backlogs in the previous semesters, who have joined late during their first year, and who has come across all the semesters with greater than 75% attendance, and who has received at least one time as a topper in the semester. So like that, if I correlate multiple questions, then obviously it becomes a multi-hop reasoning. Okay, a multi-hop task. So a traditional RAG will have a poor performance on such particular multi-hop reasoning task, because it need to go with multi-dimensionality and then work out, then come up with a solution. And it has an inability to handle ambiguous or under-specified queries. So there may be a situation where even LLM also goes in a state of confusion, where it can't exactly specify, because sometimes even when you are working on a traditional classification models also, you do go for an overfitting and underfitting. So what exactly that means? Without any relevance to the query being asked, or without any relevance to the given input, it gives a maximum accuracy irrespective of that particular data which is being contained, or whichever test data is provided, irrespective of that, you'll be getting a accuracy. So why it is happening? Because of the ambiguity which is generated in the model. So traditional RAG, there is a chance of getting an ambiguity which it is not in a position to handle properly. So agentic RAG, to deal all these particular problems, we'll be adding autonomy where it can think on its own and regenerate the answers with a proper reasoning, that is justification provided to that particular answer, and then adaptation to the existing query. So adaptation means it molds itself or it updates the knowledge base, and then that knowledge base will be in synchronous with the database of the LLM. Okay. So likewise, will be the agentic RAG will focus all these problems of the traditional RAG. Now, as I told you, there are 4 generations of RAG. So first, a Navy RAG, which started from 2020 and almost for 2 years, it focused mainly on the generative AI content. That is, it was only focusing on the embedding, retrieving top K, and then based on the query asked by the end user and based on the prompt provided, it has generated the solutions. So it is almost acting like a traditional RAG to some extent where the speed was improved. So it is simple enough, speed was improved, but accuracy was only to 70 to 80%. Then came advanced RAG, where we focused on query rewriting, re-ranking, and hybrid search approaches. So most of the time, search approaches, we go for A-star search approaches, which was one of the good searching strategy, which is an informed search strategy. Then goes for better chunking, metadata filtering. So rather than going as a single answering, a single line answering, or giving in a single pass, giving a solution in a single pass, it goes for decomposing the given query into multiple chunks, where each and every chunk will focus on precise meaning, what is being asked by the end user, and then search based on the metadata filtering. So what do you mean by metadata? Gives a detailed information about the data which is present in the database. Okay, so there the accuracy was increased up to 10% when compared to the Navy RAG. So it went to 80 to 90%, but still it was maintaining only a static pipeline. Okay, it was not focusing on the knowledge base. Then later came modular RAG, where the last 2 years they focused on the modular RAG, routing, scheduling, and fusion strategies. So here came the involvement of the multiple knowledge bases and database versions. So where the solutions which were received from multiple sources were combined using various fusion strategies, and multiple retrievers was there where there was an active learning. See, whenever there is an involvement of knowledge base, obviously the learning will shift from passive to active. So there is an active learning being taken, and it was more flexible when compared to the earlier Navy RAG and advanced RAG, but still it was not completely autonomous. Okay, so when the autonomous was included, when the AI agents and machine learning strategies were embedded into RAG along with the knowledge base which was maintained, then resulted in agentic RAG, where the current version we are working on the agentic RAG, where we was completely focusing on the autonomous agents with proper planning, reasoning. Without proper planning, reasoning, without any proper justification, we don't accept the solution given by the LLMs as well. Okay, so there is a concept of self-correction based on the what you can say. It is like a cycle which focuses on the feedback. Okay, like you have a concept in neural networks, ANN, artificial neural networks, and we focus on multi-hop retrieval. So where multi-hop retrieval is going through various cycles until a threshold value is reached, and of course focusing on the tools usage also. So since the data is being generated in a huge size, and even accessing also is focused on multiple parameters, so we depend on tools rather than a manual usage. And this resulted in a dynamic adaptation, memory, and orchestration. What do you mean by orchestration? Orchestration is working as a team. So when I'm dealing with multiple parameters, then I go for parallel processing, and I get the data, the whatever the service required can be generated into multiple phases, and all the phases are combined to give a overall result. So that particular concept we call it as orchestration. So since we are going for multi-hop and since we are going for multiple chunks, so the data will be taken from multiple chunks, then it goes for multi-hop retrieval, then finally moves towards orchestration to give a better result. So finally, we are moving from a traditional RAG to agentic RAG to ensure that you get a precise information focusing on a maximum accuracy. Clear? So the agentic RAG, so based on the history which is being discussed, then now I can come to a conclusion of or defining an agentic RAG as it's a combination where it combines retrieval augmented generation, which is a traditional RAG, with autonomous AI agents that can plan, reason, and adapt their retrieval strategies dynamically. So focus on the terms autonomous, then focus on the term retrieval, and focus on the term dynamical. These three terms are important, which have a shift from a traditional RAG to agentic RAG. So what are the core capabilities like we have already been discussed? So just to list out, first we focused on planning, which was not up to the mark for the traditional RAG, then reasoning, then tool usage, self-correction, memory adaptability, and then adaptation to the new, whatever the new records are coming. So it has to learn from the feedback and then improve, which is an important feature of reinforcement learning. So generally, even in machine learning strategies, we focus on supervised, unsupervised, and reinforcement learning. So reinforcement learning will learn from the feedback. So that is what, whenever you are going for multiple hops, you learn from the feedback and then improve on a timely basis. Okay, and the timely basis depends on the application area. Say for example, if I'm going for a stock market analysis, I need to go for an updation every second. Okay, if I'm going for an attendance generation in an educational institutions, I go for a hourly basis. Okay, if I go for some historical data which is maintained in a high-end organizations, I go for annual reports. So it depends on the application area. Okay, so altogether an agentic RAG is the one which is focusing on RAG, autonomous agents, and orchestration, where you are collecting the data from multiple sources dynamically. Okay, so it is just like giving a simple analogy. If I need any information, if I directly go to a librarian and then ask, I need this information, then even the librarian must also go and search, isn't it? Because the librarian may not be available with all the different books which are present in the library. But instead, if I go for a research team who are working on that specific topic, then I can get much more information, which is a good strategic information and which is verified from authorized sources. Okay, so that is the difference between the traditional and agentic RAG. Maybe we focused more on the differences, so let me just wind up with the simple differences. Like if I focus on various dimensions like this, so how the traditional RAG differs from an agentic RAG with respect to query processing. Obviously, you go for a single hop in traditional RAG, so we go for a single step retrieval, but here you go for a multi-hop. Then decision making, you have a fixed pipeline which cannot be changed based on the user query. But in agentic RAG, we go for a specialized versions, so we go for an adaptive strategy. Memory, you don't have any states here, but in agentic RAG, we do follow various states. So whenever a new query is coming or when a new prompt is coming from the end user to the LLM, then we create a different state based on that particular query. If the query is having a complex, it's more complex, then you will be having more number of states available. And similarly, all these are being stored in the memory. Then adaptability, you have static responses in traditional RAG, whereas in agentic you have dynamic responses based on the interactions. And complexity handling, traditional RAG can only handle simple queries, but whereas agentic RAG can focus on multiple queries and even multiple dimensionals as well. Then self-verification, there is no any self-verification in traditional RAG. If it is available, well and good, it will give whatever available with it. Otherwise, it will give some hallucinated data. So you can't exactly validate it. But when you go for agentic RAG, you have a perfect validation and reflection with respect to the related sources which are authorized. Then cost predictability is high in traditional RAG, but in agentic RAG, because I am moving for tools, you may think, sir, why agentic RAG is lower in cost predictability? Since I am focusing on tool for the majority of the purpose, so it depends on simply the loop length, okay, or the loop depth. Then latency for traditional RAG is predictable, but whereas in agentic RAG it varies, and that variation depends again on the number of loops or number of hops. And then debugging for traditional RAG, a smaller surface, but agentic we go for a larger surface, and obviously it will be more complex. So to choose, I mean, whenever I'm going for giving a query to the LLM, now whether I have to depend on a traditional RAG architecture or an agentic RAG architecture. So there are only two things you have to focus on. First is what is the complexity of your query. So whether it can be solved in a single step, or whether it is focusing on a single dimension, or whether it is focusing on multiple dimensions. Okay, if it is multiple dimension, it is better to move towards agentic RAG. Okay, and then the second one is what is the accuracy level? What is the accuracy level you are expecting? Okay, or if you are getting some error, so to overcome that error, how much amount of time I have to spend, and how much cost should I invest? Okay, so these two are the main reasons in selecting whether to move towards the traditional RAG architecture or agentic RAG architecture. So, as depicted in the picture, this is an agentic RAG workflow. So, if I don't have any available function included, if I have only AI agent application, prompt, LLM layer, only the three components are available, then it is a traditional RAG. But you can see the flow from AI agent application. You are giving a prompt or using some tools based on some available functions, and then you are moving to the LLM layer. So it may be it may be a meta heuristic, or it may be a chat GPT and OpenAI, or any AI application, then you get a result. Okay, but if I want to include more knowledge in it, then I need to focus on various available functions, maybe the functions of the tools, maybe the action functions, LLM functions, and also retrieval functions. And based on these functions, I'll be getting a persistent knowledge. Then the AI agent will depend on this persistent knowledge, which is nothing but the knowledge base, which will focus more on the vector database. Okay, relational database and graph database, even a traditional RAG will have, but vector database is the one which changes dynamically and which is the core component of the agentic RAG. Okay, and these are the key components. You have an orchestra, because which is the main component, which is also called a meta agent. So what it does, it goes for receiving a user query, plans execution strategy, and delegate the subtask, because you are dividing the entire complex query into various chunks. So each and every subtask will be assigned or delegated to the specialized agents which are available in the architecture. Okay, and these specialized agents will further retrieve the data. So the second part is focused on the specialized retrieval agents. So you may have a document agent which is focused on the unstructured PDFs, then SQL agent, a SQL agent which is focused on the structured databases, an API agent will focus on the external services and all the application programming interfaces. Then the graph agent, which is traversing the knowledge graph. So what are these knowledge graphs? Knowledge graphs are the graphs which are being generated from the knowledge base. So you'll be getting a taxonomy of the entire knowledge which can be predicted in a form of a knowledge graph, and knowledge agent will take care of this knowledge graphs. Okay, so all this put together is aggregated and given as a final solution, and which is we call it as a validated solution. So then coming to that validation, you have the third phase, which is reasoning and planning engine. So whenever we are going for various chunks, that is, you are going for a decomposition, then query is also being split up accordingly and is processed in individual chunks. So that you call it as a query decomposition. Okay. Then at each and every decomposition phase, we ensure that that particular sub goal is being generated. Say for example, if I give a query having six different dimensions, so I'll be dividing that particular query into six different chunks where each and every chunk will focus on a single dimension. So from that particular direction perspective, if the goal is being achieved, then I call that the sub goal is being generated. Now similarly, when all the six sub goals are generated, then I ensure that I get an overall solution for the given problem or for the given query. Now similarly, there must be a strategy selection and tool orchestration. So everything must be a well planned, and the two, it must be an authentic source of planning. Say for example, here planning is also one of the important strategy selection. Now what do you mean by the strategy selection? Say for example, uh, there are many situations where we organize various events in the universities and colleges, right? So sometimes there may be a situation where we go with a well planned event, and obviously that well planned event will be a success. But there may be a situation where we go for an ad hoc planning. Just a day before or within the same week, you get some instructions from the higher authorities and you need to plan accordingly. So at that time, you go for the ad hoc planning where some things you plan on your perfectness, or something you just go for a trial and error basis. Isn't it? So sometimes, so in such situations, there may be a success or there also may be a failure, isn't it? So whenever you are dealing with perfect applications like this, we don't adopt any ad hoc planning. We go for a fully strategic planning. So you need to select the strategy well in advance. Then accordingly, you go for the tool selection as well. Yeah. Then memory and context management. So memory and context management, whether it is a short term or whether it is a long term. Whenever it is a short term, it purely depends on your conversation, what you are communicating with your application. Okay. Mostly, say for example, if I'm using a chat GPT or whether I'm using a Kimi tool, okay, when I'm using a Gemini application. So mostly I'll be going with respect to conversation history. Okay, even in future also, when I want to go check, I can just check my chart history so that you can continue that. That is called a short-term conversation. Okay, but when you go for long-term, it focuses on the user preferences. So what user is expecting? The user may have some query yesterday, but today that query may change. Okay, you may come up with some other query. So that preferences will be updated on a regular basis, and you also must have a learned patterns. What do you mean by learned patterns? Whatever the knowledge which is being generated after the user query, make sure that that is stored in the knowledge base, so that in future when the user is coming up with a similar task, you can apply the same or you can use the same knowledge and proceed further. So for that, you'll be storing the patterns in the knowledge base, which you call as the learned patterns. Fine. Then you go for evaluation and feedback loop. As already discussed, you have various evaluation criteria. So here in Agentic RAG, we'll be focusing on answer validation. So on what basis that application has given or LLM has given that particular answer, it gives the sources. And that is the reason you have come up now, people are coming up with explainable AI. So what is explainable AI? Now mostly people are using generative AI. Okay, like you can take an example of ChatGPT. It's a generative AI. Okay, but when I want the sources, so it has given some solution, but what are the sources it has used to generate that particular content? So if I need all that sources also with a proper validation, then you call it as explainable AI. Okay, so answer validation is required. Then hallucination detection. So as I told you, sometimes the LLM may predict or may give solution as if it knew the answer, though the actual content is not available with it. So you must predict whether it is giving the correct answer based on the resources it has gone through, or is it just going for an hallucination. Okay, so that can only be achieved by checking the evaluation metrics, and then focusing on the self correction and confidence scoring. So even this also you can focus on the features like true positives, true negatives, false positives, false negatives. Okay, so when you go for true positives and true negatives, which will give you the accuracy levels, and the remaining two contents, false positives and false negatives, are the erroneous content. So that erroneous content must be corrected. So it has to go for its self correction and then ensure that it is moving towards 100% accuracy. Okay, and these are the real world use cases. Like you can focus on the financial services. Don't want to focus much here because I need to cover the content. So focusing on the financial services, then healthcare and life sciences, legal and compliance services, enterprise operations. So most of my slides are self-explanatory. So I'll also pass on my slides to the coordinator. You can go through the slides for in detailed discussions. Okay. So applications part, I'm not focusing on the use cases. So let us quickly now move on to what are the foundations of RAG. So the core idea, so in fact, as we already discussed, RAG enhances the LLMs by dynamically retrieving the relevant information from external knowledge sources and incorporating into the generation process. So what is the core idea in this? So if I am only using LLM, then it is a pre-trained model. Pre-trained model, you can also call it as a static, and which is frozen at cutoff date. As I have just now used an example of the latest version of ChatGPT 5.3, where it was released on April 23rd, 2026. So it had all the trained data till that date only. Now beyond that, if I am giving, it may not give, but it will predict. It will predict as a part of hallucination and then gives the related answer. But when you go for RAG knowledge, RAG knowledge, we focus on the dynamic. We focus on the real time, domain specific. So whatever, say for example, if I am focusing on IPL, okay, so the ChatGPT 5.3 will not have that information because it is after April. Okay, so when you go for RAG knowledge, you'll be having a related content from the domain specific. So it will be taking from the related sources or what are the authorized sources of cricket. From that, it will take the content of the IPL, then gives you the related results. Okay, and the three primary components of RAG: retrieval, augmentation, generation. So you know retrieval means simply getting the data. Even when you go for a normal SQL servers, so how you, based on your query, the data is generated from the tables. Okay, it can be a vector databases, it can be an APIs, or it can be any knowledge bases. Now, what do you mean by augmentation? What exactly you mean by augmentation? So processing the retrieved data and extract the relevant content. So augmentation is nothing but whether whatever the data which is being retrieved, whether it is correctly provided or not, and whether it is relevant to the question being asked or not. Okay. So to some extent, validation is already done at the augmentation level. Okay. And then finally, after that validation is done, that validation is also done from multiple levels, or as we already discussed, multiple chunks. We divide the given query into multiple chunks. So the augmentation is done at multiple levels or multiple chunks, and finally combined that particular information with the LLM knowledge for a final responses. Then you get the final response being generated. So that's the reason you go for retrieval, augmentation, generation. So that's the reason we call it as RAG. Okay. So it grounds the LLM outputs in factual, up-to-date information, reduces hallucinations, enables access to enterprise data. So what do you mean by enterprise data here? Enterprise data is nothing but a data which is more relevant and more related. When I go for a data warehouse, you have a generic information, you have an overall information. But when you are focusing on the enterprise data, or you can also call it a data mart. So what are data marts? Nothing but a specialized information available in the that particular. Say for example, let me take an example of a college, an educational organization. So a student database may generally have hundreds of attributes, hundreds of features. But when I go for department, I'll be focusing mainly the registration number, name of the student, the parent contacts, the student contacts, okay, attendance, all that I'll be taking care. When I go for the same towards the examination branch will focus on the marks, individual marks, the two internal marks, external marks. From that, again, the data will be transferred to the department. Okay, department will not take care of the marks. It will be obtained from the examination branch. Okay, similarly, when I go for the account department will focus on their date of admission, what were the fees provided for that, how much you are getting from the reimbursement, how much you are getting from the parent. Okay, so like that, such information, or is the student having any scholarships? So such kind of things are maintained at the account level. So all this put together, I call it as a warehouse. Okay, so this individual data you call it as enterprise data or data marts. So that's the reason you call it as a private data or enterprise data, right? So RAC provides an access to the private data because it goes towards a specific purpose. It goes towards a domain specific, or it goes for a specialized data recovery. It is not focusing on the generic data, right? And then makes LLM responses traceable and verifiable. As already we have been discussing right from the start of the session, we must have an authentic sources from which you are getting that information. So it must be a traceable as well as a verifiable. Yep. And this is a basic rack pipeline which we have already discussed. So here mainly we focus on data indexing. Why we go for data indexing? To have a quick access of documents. Okay, so we go for data indexing and then data retrieval and generation. So that data retrieval and generation will be done by a vector database where it ranks the given sources as top k chunks, just like you can see k nearest neighbor. You go for KNN algorithm where it goes for ranking basis and goes for the minimum distance record. So similarly here also it goes for the data retrieval and generation, then gives the responses. So this is a basic RAG pipeline. Then when you go for document processing and chunking, you have fixed size chunking, semantic chunking, recursive chunking, and agentic chunking. So to focus more on this, what is fixed size chunking is generally whenever you are going for splitting up into different chunks, we go for powers of 2. Okay, so that is the reason even when you go for search algorithms, you have a binary search, a linear search advancement, you go for a binary search or Fibonacci search. There you'll be going for powers of 2, 2, 4, 8, 16, 32, 64, okay, then 128, 256, 512, 1024. So like that, you'll be going for powers of 2 so that it is easy for processing. Okay, and then when you go for semantic chunk, it focuses on where exactly the sequence of the query is ending, whether the end user is giving other paragraphs or end user is giving any section. Say for example, I want to generate some important questions for students. So I'll be giving a certain prompt for LLM saying that, dear, I want 100 important questions from the syllabus attached, okay, based on the Bloom's taxonomy levels. Okay, so now it need to go for various sections. Now it need to split. First one is I gave 100, the count. Then I gave important questions based on the Bloom's taxonomy. Okay, so like that it goes for paragraphs, sections, how the person or what is the intent of that end user. So it preserves the content and goes for betterment for the retrieval quality. Then recursive chunking. So recursive chunking, sometimes there may be a query which is asked as a part of taxonomy, that is level by level. Okay, so when I'm focusing, say for example, I want to, the management wants to give a vacation for the faculty members. So whenever is going for a vacation, so first we go cadre. Okay, generally the directors or the head level people generally get uh, less vacation because they'll be given more work during that period. Okay, then comes the number of years worked in that organization. So what is the experience of the faculty member in the organization, right? And then based on the joining date, because generally if it is less than 6 months, not eligible for vacation. So such kind of things, you have different level wise or ranking. Okay, so which you call it as a taxonomy level or hierarchical splitting. So based on that hierarchical splitting, you go for recursive chunking. And the last one is called agentic chunking, where it is completely based on the LLM based intelligent segmentation. So for the optimality, see, whenever someone is asking what is an improvement from the traditional rack to agentic rack, the main thing is you are moving towards optimality. So optimal with respect to cost, optimal with respect to accuracy, optimal with respect to time, optimal with respect to space, optimal with respect to the query. Okay. So it depends. Now the word optimal is a generalized again. Now with respect to cost, it must be minimized. With respect to time, it must be minimized. With respect to space, it must be minimized. With respect to complexity, it must be minimized. Okay. And with respect to the query, it must be maximized. Okay. It has to cover all the specific features of the query, right? And then when we are going for the best practices, though we are dividing into various chunks, we go for a chunks where the chunks are overlapping. We don't expect chunks to be isolated because there must be a continuity. So that is the reason we maintain 10 to 20% of overlapping between the chunks for context preservation. So it is something like whenever you are going for a sequential chunks, the output of chunk 1 will act as an input for chunk 2, and output of chunk 2 will act as an input to chunk 3, isn't it? So then if there is an overlapping, okay, need not be 20%, at least 10% is preferable, so that there will be a continuity maintained between the solutions which is given for the individual chunks. And then embed metadata. So metadata is nothing but a detailed information about the features or detailed information about the data set. Say for example, generally when you go for a data set, sometimes you generate your own data sets or we depend on the web sources. So when you go for web sources, whether you take UCI repository or whether you go for Kaggle data sets, will be having a detailed information: who has generated the data set, which year, what was the purpose for the data set, how many features the data set is having, how many records it is having, and each and every feature, what is the kind of the attribute it is, whether it is a categorical, whether it is a numerical, okay, whether it is an ordinal, whether it is a mixed type, okay, and what is the range of values. Say for example, if I'm going for a medical data set, so range of values for that particular feature will hold. Say for example, if I'm going for blood pressure, BP, so I'll be having a range 80 to 120. Okay, so like that, giving a detailed information of each and every content available in the data set is nothing but a metadata, right? And then use semantic chunking for long form documents. So it must also focus on, so that is the reason the second type of chunking strategy is semantic chunking. So why semantic chunking is main? Because I need the meaning to be preserved. It must preserve the meaning or the intent of that particular content. So that is more important, so that you can have the flow. The flow can be maintained and continued easily. And then size chunks to your embedding models optimal input length. So I can't exactly tell that smaller chunks are good enough or larger chunks are good enough. It depends on what is the length of the query. If the length of the query is more, then you go for more number of chunks. And that too, it again depends on the semanticness, it checks on the recursiveness, it checks on the agentic. Okay, so all these features are to be maintained, so that these are the best practices for document processing. So this is a comparative analysis which is focusing on all the different strategies of chunks. What is the approach, which is the best approach for that particular strategy? What is the advantage? What is the disadvantage? And what is the best use cases? Okay, like fixed size, split by token count. So it's better you go for a particular count and restrict to the count, which is a simple and may split meaning. Okay, that is the drawback. And then best for uniform documents. So uniform document is best example, as I told, attendance generation. So every time whenever I am generating attendance, the size of the data will be constant. Okay, so I can go for a fixed size chain. Next, semantic, split by boundaries. So it preserves the content, which is an advantage, but it is more complex, because uh, checking a syntacticness of a particular query can be easily done by manually or using tool. But when I go for a semantic check, it has to depend on multiple factors. So it is a complex there. Okay, and it is best suited for long form text, not for short one. And then going for recursive approach or recursive strategy, we'll be going for a hierarchical, nothing but we'll be using some taxonomy based, which is focusing on the multi-granularity, which is an advantage. But to store taxonomy level, I need to store each and every level separately in the storage. So I need have a high storage, but still that cannot be treated as a drawback, because nowadays storage is not a big deal. You can have nowadays we are working on yottabytes of data. Okay, so that is not a big disadvantage. Next, it is best for complex documents. So for complex documents, whenever you go for a hierarchical picture or maintain some taxonomy, then it will be good enough, and the processing or the accessibility of the queries can also be done at the faster speed. Then agentic strategy, the approach is purely an LLM guided splitting. So it will come up with an optimal segments, because LLM is guiding completely. But disadvantage is it is expensive. Okay, to build a single LLM, I need millions and trillions of data, and it is more costly. Okay, so it is an expensive and best suited for critical documents. Okay, which is focusing on the multi-dimensionality. Then sliding window strategy approach is overlapping chunks, which is recommended actually, because there is no any information loss, there will be a continuity. And yes, yeah, any disturbance? Any problem,
No, sir.
audience? Yeah.
Is it clear, sir?
Yeah, yeah. And one more thing I thought of telling at the beginning itself. If anyone having any doubt or any problem, you can interrupt me at any time. It's not like I'll end my entire session and only at the end you need to ask questions. You can interrupt me at any time. Okay. But anyway, once completing this particular part, then we'll go for a break, because I was instructed to give a break at 2:30. So the advantage is you don't have any information loss, but since 10 to 20% of content is overlapping, then obviously there is a chance of redundancy. Okay, but of course, though, see, each and every strategy will have some advantages and disadvantages. So our intent is to focus more on the advantages side. So since there is no information loss, even if it is redundancy also, it will act as a further verification and validation. Okay, so whether it is being continued or not. And it is the best for dense content, having a huge amount of data where it is overlapping. The best example of this is you can take an example of random forest. Random forest using a sliding window strategy. And then embedding models for RAG, I need not discuss more here. I'll just focus on the key considerations. So why these embedded models are there? Embedded models to convert a simple text to the vector representations. Okay. And the key consideration is context length. Okay. So it must exactly match with the chunk size, whatever being planned as a fixed length. And then domain adaptation is must and should there, and whatever the overlapping is there, it must match with the accuracy also. And then multilingual support, it has to support multiple languages, like say even when you go for LLMs also, even if you give a query in native languages, even if I give a query in Telugu or in Hindi or Marathi, in any language, it gives some solution or it gives some answer. So it is not restricted to only English language. So multilingual support is also required. And then latency versus quality trade-off. So always this is a challenge. So whether quality is to be maintained or whether I need to go for more toward the inference. Okay. So always our motto is to move toward the better quality. Okay. Like say, for example, if I go for even complexities in analysis of algorithms also, I go for time complexity and space complexity. Okay. So if I have an algorithm which has a less time complexity and more space complexity, on the other side, I have an algorithm with more time complexity and less space complexity. So which one do you prefer? Yes, audience? Which one do you prefer? So there is an algorithm one with less time complexity, more space complexity. There's another algorithm with more time complexity, less space complexity. So which one do you prefer? So there is a trade-off between the time and space complexities. So in that scenario, which one do you prefer? Yes? Any answers? Am I audible? See, if I don't get any response, I have to check my connection first. Am I audible?
Less time complexity.
Exactly. So you need to prefer less time complexity and more space complexity because time is more important for us. Okay. I can purchase a 1 TB of hard disk for some 5,000 rupees. Okay. But can I purchase 5 seconds of time? No. So obviously the preference to be given for the time complexity. Right? And then we also have vector databases. This also I don't want to focus much because just I focus on the critical features, like we go for a hybrid search, metadata filtering, which was already discussed in the previous slides. Now, these are the similarities search and the ANN algorithms. So ANN algorithms is not artificial neural network, it is approximate nearest neighbor. Okay. So what is this ANN algorithms? They enable fast similar search in high dimensional spaces. Like just now I used one algorithm called A-star algorithm. So A-star algorithm was the best informed search strategy. Even if you take an example of Google Maps. So Google Maps uses A-star algorithm. Now similarly, when you are going for RAG architectures, we focus on hierarchical navigable small world, invertible file index, product quantization, disk-based approximate nearest neighbor search. Okay, so all these algorithm focuses on certain distance metrics. Okay, you might be already aware when dealing with clustering algorithms, we focus on Euclidean distance, Manhattan distance, and Manhattan distance and Minkowski distance. But out of all them, you are all aware that Euclidean distance are the most widely used So here also you will be going for the Euclidean distance where magnitude matters, and we use cosine similarity, okay, for the normalized vectors, and we use a dot product when going for unnormalized embedding. Okay, now when to use similarity and when to use distance. If we use distance metrics, then we focus that there must be a less distance. Okay, and if you are focusing on the similarity, we focus on a maximum similarity. So these two are inversely proportional. Similarity and distance measures are inversely proportional. And then you have different retrieval strategies. So generally we go for a top tier retrieval because just like we had a discussion, KNN, K nearest neighbor. So we'll be ranking the whatever records available. Now similarly here also, whenever you are going for whether it is a traditional RAG or agentic RAG, you are going for at first ranking them. Okay, ranking them based on how closely that particular content is. Okay, so you call them as top tier retrieval, and these strategies improve the context quality, right? So you have different retrieval techniques: dense retrieval, sparse retrieval, hybrid retrieval, multi-vector retrieval, and context retrieval. So just you can go through the slides. Then re-ranking for precision. So why re-ranking is required? Because the reason for moving towards agentic RAG is to increase the preciseness. So preciseness is precision. So what do you mean by precision? Or how can you define a precision with respect to the confusion matrix? Yes, audience. How do you define the precision with respect to confusion matrix? Any answers from the audience? So precision can be termed as a true positive out of total positive doubles. As you'll be having true positives, true negatives, false negatives. But when you're focusing on the positives, I get true positives and false positives. So true positives are nothing but the positives which are actually positive and predicted as positive. But false positives are nothing but they are predicted as positive, but which are not actually positive. So actually they are negative, but they are predicted, falsely predicted as positive. So that's why you call them as false positives. So precision is nothing but out of possibles, how many were correctly predicted. So that's the reason you have dash true positive by true positive plus false positive. So that is nothing but precision. And to increase this precision itself, we are moving towards agentic RAG. So that's the reason whenever there is a ranking there, and when the precision is not up to the mark, then you go for a backtracking process where based on the feedback, you'll be updating the model. So when you're updating the model, we expect that you go for a re-ranking. Okay, so that is the main reason for going for re-ranking. So re-ranking improves the precision by scoring retrieved documents with a more powerful model. Okay, and why we are re-ranking? Because initial re-ranking is fast but not up to the mark. Then we go for more accurate. So again here, when there is a trade-off between the accuracy and speed. Say for example, if you complete a project within a week, but the accuracy is only 50%. But if you are completing a project within a month, but accuracy is 100%. So which one we prefer? Obviously, we prefer the accuracy with 100%. Okay. So focus more on accuracy. So for that, you go for different iterations. Okay. So you go for different re-ranking approaches like cross-encoder re-ranker, LLM-based re-ranking, and learned sparse retrieval re-ranking. Okay. And this is the query transformation techniques. So whenever you are going for a transformation from LLMs, we focus on first embedding, Then we go for retrieving the related content, which you call it as top K relevant documents from the vector database. And then finally, based on the prompt or query provided by the end user, it will be given to the LLM. Okay, then finally you get a solution. Okay, so that is what is being depicted in this diagram. So the proprietary data is nothing but the organizational. It can be an organizational data, or it can be some conditions. Say, for example, when you're joining an organization, you'll be having some HR policies, or even you have some leave policies. Okay, you have some organizational standards, you have some ISO standards maintained by various industries. So all these you call it as the proprietary data. Okay, even proprietary data may also include the time for completion of the project, the cost which can be invested for the project. Okay, so all these will be stored along with the user question, user query. Then it searches from the vector database the related content. Then it ranks the top K relevant document. From that, based on the initial query provided by the user, some more context is added, which you call it as the prompt. So whenever you are giving some query to the LLMs, you call it as a prompt. Okay, so that prompt is given to the LLM, then you get accordingly the solution, required solution. Okay, so entire processing is done at LLM, because LLM is not a simple thing. It is having millions and trillions of data available, which can be retrieved, and finally you get a solution. Okay, then we go for query transformation methods. So where we have query rewriting, subquery decomposition, hypothetical document embedding, step back prompting, and query expansion. So these are all the transformation methods. So why a transformation is required actually? So whenever, say for example, sometimes whatever the query being generated or being asked by the end user may not be suitable for an algorithm. Okay, so that is the reason there are some pre-processing done. So even transformation methods are a part of your pre-processing. 5 minutes just. So there is a part of transformation methods. So similarly, you have context assembly and prompt engineering, which is focusing on different strategies like stuffing, map reduce, refine, and contextual compression. Okay, so what is the stuffing? Stuffing is simply nothing but getting them together or merging them, or in a simple words, you call them as concatenation. So concatenating the solutions which is obtained from the individual chunks and putting together, you call it as the stuffing. Okay. Then map reduce are used for synthesizing. So whatever the processing is done, individual chunks, they are synthesized so that it can handle the complete query, or it can handle the huge documents, that too in a parallel mode. It is not a serializable, it is parallelizable. So parallelly it has to handle. And then refine. It iteratively refines the answer with each chunk. So why this refinement is required? For a better accuracy or for a better understanding to the end user. Because whenever you are giving some complex query, it is being decomposed. Now again, when individual chunks are being processed, I can't give that individual answers to the end user. Again, I have to refine them and then provide in a proper way so that his purpose is justified. Then contextual compression. So summarize the chunks before inclusion. So reduces the token usage, focuses on essentials. So why we have to go for reducing the token usage? So generally, the purpose of token comes when you are going for the segmentation. So in fact, you'll be having certain processing like tokenization, segmentation, okay, and then legitimation. So why these are required? To ensure that you're not focusing on only the syntax part. You must also focus on the semantics part. When you're focusing on the tokens, it is only focusing on the syntax part. But I don't want to only restrict myself to only the syntax part. I must also focus on the meaning, semantics of that particular context. Okay, so then focus on the essentials. So these are all the assembly strategies required. And then prompt engineering best practices. So these are the best practices, include the source citations for traceability. So not only for traceability, it also acts as a good source for future documentation. So whenever you are doing a product, it is better you try to come up with some explanation or give some remarks. So when you give some remarks, it acts as a source for the future documentation. Even the person who is using that particular product in the future will go for the documentation and will understand that okay, you have taken sources from so and so sources to do that particular content. And then instruct the model to say I don't know if context insufficient. So that is the reason just now I told you, rather than hallucination, because when you go for hallucination it gives some or the other answer, but I don't want rather than LLM being a fool, if it is giving some of the other answer, some related answer, then end user will become a fool. Okay, so instead of that, it has to tell like I am still in a training stage, so give me a chance to train. So you can generally, if you focus on IVRS systems of gas booking, then you'll be getting such answers. Okay, so it will not just give some random answers. It will strictly focus on some menu. Okay, one for booking a cylinder, two for some options and all. And if you are giving some other than that option, then it will give a message saying that I'm still at the training phase. So please try to give the related information or go back to menu. So like that, it has to give so that the user also feels that okay, it is not or it is an invalid question. Okay. Then use system prompts to define persons and constraints. So what is persona? Any specialized information provided, and constraints are what are the conditions imposed on that particular query. So that are to be maintained or well defined. Then structure context with clear delimiters. So delimiters are nothing but say for example where the context is ending. Where if I am using a comma, then there is a break provided. Where I am using a full stop, then it is a stop to that particular paragraph or particular line. Okay, or generally you'll be using a dollar symbol to ensure that there is an end of a string. Such delimiters are to be provided. Okay. Then you have RAG failure modes and root causes. So you can go for all the majority of them were already covered. So I want to skip this slide. Okay, missed content, irrelevant content, lost in the middle content, overload, generation failures, hallucination, misattribution. What is misattribution? Information is correct, but it is not fitting into that attribute. Okay, then partial answer, contradiction. So contradiction means whatever the LLM is generating is not fitting to my expectation or it is not matching with my expected result. So it becomes a contradiction. Then system failures like latency, cost and scalability. Okay. And okay, I'll just complete this slide and go for a break. And moving from NEMI to advanced RAG, we went for 4 different stages. Already we discussed from 2020 to 2022, then 2024, 25, and currently Agentic RAG in 2026. Okay. So what was the upgraded path? So first it was fixed chunking, then the method used was cosine similarity, then directed generation. Rather, the fixed chunking was upgraded to semantic chunking. Then from semantic chunking, it uploaded to scheduling. Then from scheduling, it got upgraded to autonomous planning. So this was the flow upgraded path. Now similarly, the cosine similarity was replaced by hybrid search, then hybrid search to scheduling, fusion scheduling, because it means fusing from multiple hops, and then finally going for the self-correction and improvement. Okay. Then similarly, when I'm going for the baseline, accuracy is 70 to 80%, then improves to 85, then 90, then now moving towards 100%. Okay, so a quick upgraded path, because already these also we have covered in the earlier slides. So I think maybe I am a bit fast, because I was given time only till 4 o'clock. So I thought of covering the majority of the content. So let us have a quick break. So before that, let me ask any questions, audience, from your side? Any questions? I was given break time from 2:30 to 2:45, but anyway, I'll give a break till 3 o'clock now. So if you have any questions, please turn on your video and ask questions, so that I feel that okay, the faculty members are listening my session. Yes, anyone from the audience, please. As all our faculty members, I need not tell. If we get questions from students, then only we feel happy about our lecture. Any questions? If I don't get any questions, there are again two possibilities. One is each and everything is clearly understood, sir, or sir, we are not understanding at all. At least from the coordinator. Madam, any questions so far, or did you get any messages in the chat? Let's see, 75 audience. Any questions? Or shall we have a break and have a question and answer session at the end? And shall we go for a break now?
Yes, sir.
Okay, madam. Okay, since I'm late by 8 minutes, so let us have a session at 3 o'clock sharp.
Okay,
I'll be
sir.
in the session. Please don't quit from the session, audience. Just put your mic in a mute, video in a mute, and then have a break. We'll resume at sharp 3 o'clock. Thank you. Thank you for your patience listening.
Okay, sir.
హలో. ఆహా లేదురా, వేరే వర్క్ లో ఉన్నా. చెప్పు. తిన్నా. ఏం చేస్తున్నావు? నువ్వు తిన్నా? ఇంకా లేదురా. వెళ్ళలా. ఆ, ఇల్లు చూసాంలే. ఇల్లు చూసాము. శుక్రవారం వెళ్దాము అనుకుంటున్నాం. ఆ స్కూల్ కూడా ఇక్కడే మాట్లాడా, శ్రీ చైతన్యాన్ని. అక్కడ నుంచి ఇక్కడ ట్రాన్స్ఫర్ పెట్టాను. ఇల్లు కూడా స్కూల్. సరే. ఇల్లు అందుకే ఇల్లు చూసా. ఈ బావే చూసాడులే. ఇక అదే శుక్రవారం మంచిదని ఈ వారం అంతా స్కూల్ కూడా పోయింది. ఎవరికి చెప్పలే ఇంకా. ఈ ఆడ కుదరట్లేదురా. ఫోన్ చేద్దాంలే వెళ్ళేటప్పుడు అను. ఎక్కడున్నా నువ్వు? అదేంది?
Shall we start the session?
Yes, sir.
Yeah.
Hello, sir.
Yeah, 75.
So your voice was not clear.
No, madam, no, I'm not yet started. I'm just checking out the count and the names.
Okay, sir.
Okay. I hope I'm audible to everyone. Yes?
Yes, sir.
Yeah. So let us move on quickly to the agentic RAG architecture. Uh, Here, like in the previous discussion, before having a break, we had a discussion that embedding, then vector database, then whatever, what exactly the vector database is, it will be storing the knowledge base in a proper order with respect to hashing or whatever the retrieval strategy being followed by the algorithm. Then it will be given to the agent. So why this agent is involved? See, you're having a user, then you're having agent as well. Why agent is involved in RAG architecture, agentic RAG architecture? Because agent is the person who will take care that whether the user requirements or user queries is matched by the vector database or not. So without that agent, earlier whatever we have seen the traditional RAG architecture, you don't have any agent. Okay, but now you have an agent, and the meaning of that or the purpose of that agent is to focus on whether that matching is been, so the validation purpose. So the validation is being done. So that is the reason you can see on the top you have an architecture, orchestra, router, specialized agents, knowledge sources, synthesis. Finally, you are getting validation. So after that validation only you are given the response to the end user. Okay, and this discussion is already done. So see, I want to skip some slides now because already majority of the slides is contained, and whatever the practical part is there, you can go through it. Like you can see now, this is you call it as a reactor reasoning plus acting, enables agents to think step by step. So how the step by step is done? Say for example, the pattern which is followed is thinking, action, observation, then again thinking, finally validation, then giving up the result. Okay. Now you can see an example execution. So what was Apple's revenue in quarter 3, 2025, and how does it compare to their R&D spending? So whenever I am going for quarter 3, then I need to have an analysis of 4 quarters of an year. Then among that, I need to focus on the quarter 3. So that is my first thought. So I need to find Apple V3 revenue. I'll search their earnings report. So earnings report, if I'm having an annual earning, then I need to focus on their monthly earning first. So I think you're all aware of OLAP operations. So you have OLAP operations in data warehousing where uh, you have roll up, drill down, slicing, dicing, and pivoting. So what roll up does? Roll up will go up the hierarchy. Say for example, if I'm having monthly reports, now instead of monthly reports, I want annual report. Then I'll go for roll up. Okay. Now say for example, now here it is given as quarter 3 revenue. So what I'll do, say for example, if I'm having annual, I'll go for drill down to monthly. So from annual, I want to come to monthly. So I want to apply drill down operation. Then after getting Jan to December, now quarter 3, what is quarter 3? Jan, Feb, March will be quarter 1, April, May, June will be quarter 2, July, August, September will be quarter 3. Okay, then October, November, December, quarter 4. So July, August, September, these 3 months, again I have to apply roll-up operation to quarter level. Okay, then I will be getting that particular thought one answer, right? After that, then now I need their R&D spending for the same period. Now within that same duration of quarter 3, what was the R&D amount spent by the Apple company? Okay, then I got some retrieval like $8.2 billion. Okay, then now I will calculate the ratio and provide the answer. So earlier there, when I retrieved the revenue, I got $89.5 billion. Now I got $8.2 billion. So whenever I go for a ratio, I'm getting the result as 10.9. Okay, so then finally I'll say that whatever the question it is asked, how does it compare to the I'm having a ratio of 10.9. Okay, or 10.9:1. So like that, whenever I'm going, it may not be a direct answer. It needs some reasoning, then follows some acting policy. So once the reasoning is perfect, then you get a precise acting. Okay, so that is what is focused in the React plan. And then plan and execution pattern, I think you're all aware of this: planning, execution, and synthesis, where you will get the benefits of better handling of complex multi-step queries, easier debugging, and resource optimization. Then self-RAG. So self-RAG is focusing on a reflection mechanisms into a generation pipeline. So you'll be having a further picture of a pipeline. So how it exactly works? First, it generates the initial answers with the retrieved context. Then it goes for the self-evaluation. Self-evaluation means, does it has any proof of validation is required, or we simply call it as justification. Okay, so you try to justify your answer. So like that, the self-justification is to be done, which is called a self-evaluate. Then if that particular justification is weak, then you have to reformulate the query. That is, you need to regenerate the answer. Okay, and then perform additional retrieval iterations. So whatever retrieval are not possible at LLM level, then you have to move on to the metadata or the knowledge base. So repeat this until a confidence threshold is met, or when the maximum iterations are reached. So generally we focus on some threshold value. Say confidence threshold is 80%. 80% means at least you have to get 0.8. Okay, so if you until you get 0.8, you have to iterate the same process again and again. Okay, and sometimes you also have focus on the number of iterations. Number of iterations means, say for example, if a project is running for 3 months for an iteration, now again if you are going for one more iteration, say for example, the organization has got a standard saying that any product to be released within an year, not more than a year. Then at the maximum I can have only 4 iterations. Beyond that I can't proceed. Okay, so likewise it has to focus on the threshold value as well as the iterations, number of iterations. Then the self-reflection questions is the retrieved context relevant to the query or not? That is the first question. Okay, because I just don't want some vague justifications. I want the related justifications only. Okay, that's the reason even if you are going for a research paper, we'll be going for a literature survey of the papers which are closely related to that. And even if you want to give some statements also, say for example, if I want to say that 95% of cancer patients are dying without any pre-checking or pre-examinations, then immediately someone will question from where you got that value, because I can't give any value or any percentage like that. So I need to focus on, I need to take some information, say from World Health Organization, or I take some information from the Indian organization, okay, with respect to medical health. So like that, some proof is required. Without that, I can't go for even writing a research article. So that is also one of the research methodology content. And then does the answer use the retrieved context faithfully? So whether it is having what we call actually, to what extent it is useful to the market, to what extent it is useful to the society. Okay, whether it is genuine or not. So like that. And then are there gaps in the retrieved information? So in the retrieved information, do you have any missing values? Do you have any analogies? Do you have any inconsistencies? Do you have any outliers? Okay, so all these also, do you have any what do you say for example, if I'm integrating data from multiple sources, so I may have different units. Okay, say for example, if I want to integrate sales, like in the previous slide we had an Apple company illustration. So I have to go for, if I want to go for all the country's sales, so I'll be having in dollars, in rupees, in yens, in pounds. So I need to go for transformation into a global standard. So global standard, obviously I go for a dollar. So like that, all these gaps are to be identified and then checked whether all the gaps are being filled or not. There must not be any inconsistencies in the data or information retrieved. Then should I search different sources or reformulate? So shall I go for reiterating the process, or shall I completely change the sources, what it has used, and then go for a fresh search? So that is also important. Okay. Then the benefits for self-RAG is reduces hallucinations. So obviously all the variations of RAG are to reduce the hallucination through self-verification. The self-evaluation stage is important. That improves the answer completeness via iterative retrieval. So how we are retrieving from the various sources, through that the completeness will also be improved. And then adapts retrieval depth to query complexity. Okay. So this is a picture, a blurred picture. So I'll just tell. So once a query is given by the end user, so first you go for indexing. So indexing can be done through hashing or any algorithm. Fast indexing algorithm can be used. Then you go for retrieval of the relevant documents. Then you go for further generation. Okay. So this is how you get the solution after this. This is called the self-RAG flow. And then corrective RAG flow. So corrective RAG flow is focusing more on the accuracy. So corrective RAG flow, when you call it as a CRAG, it evaluates, dynamically evaluates retrieval quality and takes corrective action. So to what extent it is correct? Do you have any ambiguous information? And to what extent is it incorrect? So there are three things totally. So ambiguous means the LLM itself is not in a position to take a decision whether it is correct or incorrect. Okay, it is something like when you are going for a rough set theory or rough set approximation, you'll be having an upper boundary, you'll be having a lower boundary, and you'll be having a boundary region. So upper boundary is nothing but that particular component or that particular object belongs within the class, and lower approximation, it is not belonging to the class, and boundary region is exactly on the border. So majority of the time it can be considered to be belongs to the class, or to some extent it cannot be considered. So that is nothing but question of ambiguous. Okay, a mixed relevance. Then what are the corrective actions? So for ambiguous, augment with web research results. So what is augmenting? Writing the justifications, what are the sources it has searched. Okay, so all the detailed information is required so that we can go to the next level of validation. And for incorrect, simply rewrite the query and try for different retrievers. And for correct thing, proceed with confidence weight generation, and you can directly provide the answer to the end user. Okay, so through this you'll be getting a knowledge refinement. And then multi-hop RAG. So what is hop? Nothing but iterations, different iterations, or you can go for different dimensions. Say for example, here you got an example. It is a query with involving multiple dimensions. So which company founded by a PayPal co-founder invested in the AI startup that created GPT-4? So first iteration, you identify who created GPT-4. So I get a solution of OpenAI. Then find investors in OpenAI. So you get Microsoft and other corporate people. Then check which investor was founded by PayPal co-founder. So first one is Elon Musk. Okay, so he's not an investor. Then Peter Thiel, founders fund invested. Okay, so like that, I went for 3 iterations. Now even I gave an example of a student, like who got more than 75, didn't had any backlogs till now, okay, or stood top in the class at least once in a semester. So like that, when I'm including multiple dimensions, then you call them as multi-hop. It's a multi-hop query. Okay, so implementation approaches. If it is using a previous answer as the next query, then you go for iteration, iterative retrieval. Okay. Instead, if it is going for exploring multiple reasons or in parallel, then you go for a beam search. So beam search always go a parallel searching strategies. So at the end, again, you'll be going for a majority voting. You go for a majority voting. Say for example, 3 searches are there, multiple reason paths are there. In 2 it is getting yes and 1 it is getting no. Then 2/3 I am having yes, so I can conclude that yes is the answer. So like that you can go for a majority voting. Or third one is graph traversal. So follow an entity relationships in knowledge graph, and then we will come up with again a taxonomy. When you are going for graph traversal, say for example, you have a best graph traversal techniques, BFS and DFS. So which will focus, if I am going with respect to child, first then siblings, I go for DFS. If I am going for siblings first, then move towards child, I have BFS. So like that you have some graph traversals which will follow the entity ER diagrams. Okay, and here the challenges are error propagation, exploding search space and latency. So error propagation, generally when you are getting immediate error and which is transmitted to the next phase, then obviously the final result is also not an accurate. So it is simply disturbing the entire model. That is a major challenge. Then exploding the search space. Now, whenever you are going for various confidence levels, when I told a confidence level must be met, or when the number of iterations or the maximum number of iterations are met, then we need to focus on to what extent I need to continue the search space and in what extent I can ignore. So ignoring or deleting the search space which is irrelevant for my question is nothing but pruning. Okay. And then coming to the latency, each hop adds retrieval plus generation time. So every latency is focusing on to what extent the retrieval was done and what was the time taken for that single iteration. Then tool use in agentic rack, you have different tools being used. You can just go through the tools. I'll just skip these tools. And then function calling and tool orchestration. So this is also with related to tool which uses an API, application programming interfaces. What are the different functions depends on each and every, it varies from every tool. So based on the tools, you'll be getting the architectures. And then memory and context management. So whenever you are going for short-term memory, you focus on the current conservation. The best example is AI tools which we are regularly using. Okay, like ChatGPT or Kiwi, whatever tools we use. And then long-term memory, when you are focusing on the learned pattern and domain knowledge accumulated over time. So whenever you are focusing on the domain knowledge, I can store it as a historical data, which can be used for future processing. Okay, so that particular thing you can call it as a long-term memory. And then procedural memory, how to perform the task. So how the tool uses the patterns to predict the values. So that particular part you call it as a procedure. So a particular procedure is followed. The procedure depends on various algorithm which we'll be using for the retrieval purpose. So these are the autonomy levels. So the comparison tables and all are easy to understand. They are self-readable, so you can I can skip these. So this is a summary for the agentic rack. Then moving towards multi-agent rack systems. So why we are not going for multi-agent rack systems rather than a single agent rack system is the drawbacks. It is a one-size-fits-all retrieval strategy which cannot be suitable, which is not suitable for a complex task. So whenever I'm in complex query, just now we have seen an example which involves 3 dimensions. So I have to go for 3 different hops. Where 3 different hops are there, each and every hop can be controlled by an agent. So a single agent, if I'm going for a single agent, then I need to go for first hop, then going for the second hop, then going for the third hop. So it simply wastes your time. Okay, so it is not recommended. So you go for multi-agent RAG. Then cannot specialize for different data types. So whenever I am going for any particular query to have an optimistic one, I need a single format. But when I'm having multiple formats, like 3 hops as I told, one may use SQL, one may use PDF, one may use API. So whenever I'm using multiple types, then having a single agent will create an ambiguity. So it will create an ambiguity. So to avoid that ambiguity also, it is better you go for a multi-agent, right? Then bottlenecked by single reasoning thread. So any constraint, if you impose on any particular query, it will not be suitable for all the different dimensions. Okay, so that query may only be suitable for a single dimension and will not be applicable for the other 2 dimensions. So even in that situation also, single agent will fail. Then no fault isolation. So it is something like when you are going for a series of 3 dimensions to be processed, if one is failing, say for example, if the first one is failing, then obviously I can't go for the second, and obviously I can't go for the third. Though second and third are good enough, the process completely fails there. Okay, it is just something like a sequential electric circuits. When you go for a sequential circuits like a series bulbs in events, when I have a series bulb, if one bulb is failing, then obviously the entire series will fail. Now instead, when you go for a parallel series, when a parallel bulb lining, even if one line is failing, at least the remaining will work. Only that line will not work. Okay, the same situation is here as a single agent and multi-agent rack. Okay. This is a multi-agent RAG architecture, as I told you, based on the different approaches or different types of the data or maybe different types of the files. Different agents will take that decisions. Like I can have a boss, I can have a boss as assistant, I can have a senior Python engineer which is focusing on the implementation. I can have a product manager which is focusing on the designing part. I can have a code reviewer, okay, or reviewer. So it is something like, say for example, let me also correlate with the SDLC models. I hope you all remember that in software engineering, we have a waterfall model, which is the basic model of the software engineering architecture, which has analysis, design, coding, testing. Okay. Now, instead of that, we went for iterative methods. Okay, where we go for a pipeline process. So in the pipeline process, analysis, design, coding, testing will be done at the first cycle. In the second cycle, the first analysis part, when it is completed, we go for the second project analysis, so that the analysis team is not idle. Okay, so at the second cycle, what happens? First project design, second project analysis is being carried out simultaneously. When you are going for the third cycle, first project coding, second project design, third project analysis is done simultaneously. When you go for the fourth one, first project testing, second project coding, third project design, and fourth project analysis is done. So what is happening here? None of the team are sitting idle. So they are continuously working for the more productivity of the organization. So similarly is the situation for the multi-agent RAG architecture. Clear? Then you go for the specialization patterns. All these are the detailed discussion of the same diagram architecture, whatever discussed. So I'll directly move on to the next topic. So when you go for the multi-agent architecture, so here you can see different states, multiple states. When you go for a single architecture or a single agent, or when you go for a traditional rack, you don't have any states concept. Okay, because everything is static. But here, since everything is dynamic, you have a different states where the states must be unique. So once at the initial, whenever it is starting, then you call it as in some initial state. And when the agent interacts with customer and obtains some inputs, then we say that he has moved to some state Q1. Okay, and then based on the where exactly the person has to go. Say for example, correlate this with respect to the Google Map application, where I want to move from Hyderabad to Vijayawada. Okay, so at every junction I can include some states. Okay, so whenever I am going for some state, it indicates that okay, some 25% of the journey is completed. Okay, and how close he is to the Vijayawada. So like that I can come up with the different states for the agentic rack. So these are the frameworks for multi-agent rack systems, and these are the standard 2026 standard model context protocol, which is protocol is focusing on the rules which are to be imposed for that particular AI assistants, and these are the best practices. So majority of the slides are self-readable and already covered, so I am just skipping up. Now, focusing on the multi-agent framework comparison. So these are all the 5 different framework comparison where based on the different applications, say for example, if I am going for the complex applications, then I'll be using LangGraph. If I'm focusing on the business automation, I go for the Crew AI. If I'm focusing on the collaboration works, then I go for the AutoGen. And if I go focusing on the machine learning research, then I go for a DSPy. When I'm focusing on the document heavy RAG, that is very complex and overlapping RAG, then I'll go for the Llama index. Okay, so like that, none of the framework is completely individual or popular. It all depends on the strengths and what is the application area for which it suits better. Then focusing on the frameworks and tools, not much to discuss here. So we have a data loaders, node parsers, index structures. So all these are the core components. I'll better skip on to the architecture directly. So here, say for example, here you can see you have a LangChain core where you have chains which is composed the LLM calls, then tools and data transformations, then agents which are focusing on React, okay, reasoning and acting, then plan and execute, then tool using agents, then memory focusing on the conversation buffers, vector stores, and entity memory. Okay, and when you go for callbacks, you can have tracing. Tracing means finding exactly the location, then logging from which database or from which knowledge base that particular content was taken, and then monitoring hooks. Monitoring hooks means validation purpose. It is again for the validation purpose. So like that, getting the agent. So agent you are getting from multiple agents, and multiple agents are using multiple tools to provide the service to the query being received by the end user. Okay, then again the final response will be again given by the supervisor agent to the end user, because what happens after the input being given, just like we are going for decomposition. Okay, now after getting the through the tools, whatever the processing is done, the answer, the solutions are again given back to the supervisor agent, and it is the responsibility of the supervisor agent to give the final response to the end user. So what is happening is there, are you going for a serialization or parallelization? Yes, audience, are you going for a serialization or parallelization here?
Parallelization.
Exactly. So you are going for a parallelization. Okay. So that there is no any wastage of time involved in the patterns. The next, this is for the enterprise rack. Already we had a discussion like data marts or enterprise warehouse where these are the specialized rack architectures. So based on the pipeline based architecture, then built-in evaluation and stock typing, we go for various document stores, retrievers, generators. Now you can see OpenAI is coming under generator. So that is why, as I told you, when I even in the previous discussion, I told you it is an example of a generative AI. Okay. Then we go for evaluators. So evaluator focuses more on the metrics. So the best metrics to be used for evaluating that particular model. And then finally, agents are the elements which are using that particular outcome, then providing a structured output to the end user. Okay. And this is again database selection guide as per the 2026 analysis. So you can take, now you can see Chroma database, it is free. Okay, you can see Chroma database and PG Vector both are free, but you have got a Chroma database as widely used. Okay, though it is the hybrid search is limited, but it is best used for prototyping and local devices. So that is the reason it is more used in the current situations. So embedding model, we have completed our discussion, orchestra, retrieval, generation, cost optimization, all we have completed with respect to LLM selection for agentic RAG. Okay, so this discussion was already included. And tool ecosystem for agentic RAG, we had a comparison table. Now based on that, you can go. Now, most of the time when you are going for search and retrieval tools, so you are focusing more on the Google search programmatic access. Okay. And then if you are going for the computational tools, we are focusing on the Python replications. And when you are going for the data and integration tools, we are focusing on more on MCP, which are standardized tool interface. And when you are going for the validation tools, we are focusing more on the RAG evaluation metrics. We also call it as RAGAS. Okay. Of course, to some extent, we also use the deep evaluation for LLM outputs. Then we have the comparison study. So comparison study, now which one is used more? Widely used is Llama index, the first one. So it is used for the good agents, easy to use, production ready, and for the large community. Okay, so majority of them focus on Llama index. And then coming to the design and implementation part of RAG. So how designing an agentic RAG is done. So first we focus on the requirements, then data engineering, retrieval pipeline, and agent orchestration. So it is just like just now we had an example of SDLC, traditional SDLC model, analysis, design, coding, testing. Now similarly here also, first we have to focus on the requirement gathering. So we have to define the use cases and success criteria, identify the data sources and access patterns, determine the autonomy level, and set latency, cost, and accuracy level. So this phase is the most important. As you can see, even when you are going for the UML diagrams, once the use case diagram is ready, I hope you are all aware of the 9 UML diagrams, where we first start with a use case diagram, which focuses on the requirements. Then based on the requirements, you go for the class diagram. Based on the instances of the class diagram, we go for the object diagram. And based on the communication among the object diagrams, you go for sequence and collaboration diagrams. Then based on various activities involved in the project, we go for activity diagrams. And based on the number of states included in the project, we go for the state chart diagram. Then based on the class diagram and all these different interaction diagrams, we get various components. So with which we end up with a component diagram, and finally deploying. So when you go for the deploying, you go focus on the deployment diagram. So if you are good at these 9 diagrams, you can say that half of your project is done. So phase 1 is more important. So defining the use cases and all these, and identify the data sources from where that data is to be retrieved, and what are the access patterns. So when I say access patterns, sometimes you may give with respect to the regular expressions. So you can give the patterns in a form of a regular expressions. Then determine the autonomy levels. So when you're going for the autonomy levels, is it completely independent or depending on any other use case? So like that, you need to take a decision. Then set latency, cost, and accuracy targets. So what is the threshold values? For all these, you have to mention the threshold values. Then we move on to the phase 2, data engineering. So which will focus on whether I want to go for any decomposition, that is chunk documents or not. Then build vector indexes with the metadata. Set up hybrid search. So hybrid search means going for a multiple combination. I need not go with respect to a single search strategy. Then implement the data refresh pipelines. So you have different pipeline strategies with respect to data refreshment, data integration, and data manipulation. Okay, so all these pipelines are to be implemented properly. Then retrieval pipeline. So when you are going for implementing the data refresh pipeline, we have to focus first on embedding, which is a regular task of RAG, and then implement the retrieval strategies. So from which sources you have to do, and add re-ranking layer, because since I am focusing on the agentic RAG, I have to go for re-ranking layer. Focusing on the traditional RAG, I need not go for re-ranking. Okay, and then optimize for latency and recall, which is the final count. Because when you are going for optimizing latency and recall, then your output will be streamlined and the productivity increases. And phase 4, focusing on the agent orchestration, where design agent roles and responsibilities, implement React, okay, reasoning and acting, then plan and execute patterns, and add tool use and memory management. So which kind of tools will be used for various checks? So that decision is to be taken at the phase 4, agent orchestration. And then build error handling and retry logic. So at every level, you need to focus on the error handling. If the threshold value is met, you can move on to the next phase. If the threshold value is not meeting, then again you need to reiterate the process until the threshold value is met. So this error handling is not specifically done at only phase 4. It can be done at all the phases. Because if there is some error at the phase 1 which is not meeting the threshold value, but you are going to phase 2, phase 3 and further, then obviously the accuracy of the entire product will come down. Okay, so this error handling can be done at all the phases. Then evaluation and validation, which will focus on, because validation is the most important in agentic RAG, because earlier we didn't have validation. So if you don't have validation, then obviously LLM will move towards hallucination. So hallucination means creating its own without any proper authentic document. Then how it is creating? Just based on the previous responses. Okay, so previous responses, sometimes you may have user beliefs also. Okay, so when you have user beliefs, then user beliefs are not considered. You must either have a constraints imposed by the end user, or constraints imposed by the data analyst, or you may have an organization norms, or you can have some well-defined proved statements which can only be taken into consideration. Then product deployment, it focuses on where exactly you will deploy. So set up monitoring and alerting, implement rate limiting and cost controls, and then configure auto scaling policies. So all these are a part of your product deployment. Then we go for phase 7, which is iterative and optimization, which is the final phase. So collect the user feedback and failure cases, fine tune embedding models on domain data, optimize the chunking, that is how many decomposition you have to minimize. Don't go for too much isolations. And then retrieval strategy and expand the agent capabilities based on usage patterns. So whenever you are going for all these particular phases, then as I told you, most of the organizations will keep a cutoff of 1 year for releasing a product. Now, if you can see right from phase 1, week 1 to 2, 3, 4. Now, similarly, if a project is a huge project, just instead of week, you'll have a month. Okay, so month 1, 2, month 3, 4, month 5, 6, month 7, 8, then 9, 10, 11, 12. So at the maximum, they expect that either it must be a weekly analysis or weekly production, or it must be a monthly production. If it is a monthly production, then at the maximum it will go for a 1 year. So within that, you have to release the product. Okay. So that is data ingestion pipeline. So data ingestion pipeline is focusing on first extracting, maybe the source is in the form of PDF or HTML or SQL. Okay, then you have to apply the ETL tools. So what are ETL tools? So first you go for ingestion. Ingestion means streaming, batching, and CDC. Then ETL tool, extract, transform, and load. Okay. Then move on to the chunking process. So chunking process means decomposition. Then going for embedding. Then going for the vector database with metadata. So whatever this conformed databases, curated data lakes, Spark platforms, all these are nothing but the vector database, including the metadata. Yes. Then finally moving towards index optimization. Okay. So why we are going for index optimization? Because I want the final outcome to be a categorical. Okay. So to have a speed process, even there are situations where we, yeah, any doubts, audience? Any doubts? Yeah, please mute your audio, or if you have any doubts, you can unmute and ask questions. Okay. Then you have a query processing pipeline, almost a similar pipeline followed like earlier. Then context assembly strategies. So this all I'm just skipping out because related content. Then how do you handle the hallucinations? So which is the major challenge in the agentic RAG systems? So how that hallucinations can be detected and handled? First, you go for confabulation, invented facts not in context or parametric knowledge. Say, for example, the LLM is completely depending on the trained data which is being provided to it by the date it was released. Okay, so it is completely depending on that particular trained data only. But if it is getting out of the trained data, then whatever the content it is giving is nothing but confabulation. Okay, then misattribution. So I may have the correct fact, but the source is not correct. Okay, see, say for example, just now in the previous discussion, I told 95% of cancer patients are dying without a proper medication or without proper what you can say pre-testing and all. Okay, maybe the value is good enough. Okay, but from which source you have taken, or what is the justification, or what is the proof that that particular value is correct? Because if I directly give that statement in a public media, the people must not be panic. Okay, So that is the reason we have to go as per the Sensex of WHO, World Health Organization, or as per the Sensex of NCBI. Okay, so this many people are dying with heart disease, this many people are dying with cancer, or this many people are dying with some other disease. So there must be a proper precautions taken. So the government also can take some initiatives to prevent the disease. Okay, then overgeneralization. So like already we also had a discussion about overfitting. Okay, so extending beyond what context supports. So I want just a limited one, but it is given a full-fledged paragraph, which is not required for me. Okay, so that is the reason nowadays we are also giving LLM how much content is required, how many lines of content are required, how many questions are required. Okay, say for example, you can also generate a question paper from the LLMs. I require 5 short answer questions, 10 longer questions, okay, and 10 multiple choice from each module or each unit for the given syllabus. So I am exactly giving the count. Beyond that, I don't require. Okay. Then conflicting information. So choosing the wrong source when documents disagree. So when there is a ambiguity among the sources, it is selecting its own source. Okay, without any proper justification. So that is called a conflicting information, right? Then how will you go for different strategies? One is grounding instructions, where explicitly instruct the model to use only the provided context. So it must not go for any other context. Like you can see, you can take an example of movie Robo. Okay, so where the Rajnikant will strictly give some instructions and he has to follow that instruction strictly. So that is called grounding instructions. So penalize the answers without any source citations. Then self-consistency checks. So generate multiple answers, check for agreement, use LLM to verify claims against retrieved context. So this is only applicable when you are having multiple paths for you. But when you are having a single path, I have to restrict to only grounding instructions. Okay, when you are having a multiple paths, then I can go for self-consistency check. And next, confidence scoring. So train the model to output confidence scores per claim. So already we are having certain threshold values. If that threshold values are met, then we say that the model is good enough and there is no hallucination in the output being given by the LLM. Okay. Otherwise, if the confidence is low, then obviously there is a chance of hallucination. Then constrained generation. So always people focus on the constrained generation because when I want to get a concise and precise output, or which I can also call it as a structured output with validated fields, then I need to provide with constraints only. So I need to provide a constraint value to the cost. I need to provide constraint value to the time bound. I need to provide the constraint value to the space or memory requirement. I need to provide constraint value with respect to the person months. That is how many persons has to work on the project. I may also need to provide constraint on the LOC, lines of code, which is required for the coding. So like that, in all these you can have a constraint generation. So if you are going these strategies, then you can restrict the hallucination. The next cost optimization strategies, you have model routing, caching, context compression, token budgets, and batching. It is also explanatory. You can just go through this slide. Then latency optimization, security and complaints. So all these are already clearly given. Now next comes design patterns checklist. So when you are going for design pattern checklist, okay. So here at each and every layer, you have certain checklist to be maintained so that if that checklist is cleared, then you can move on to the next layer. Okay. So first starting with the data layer, retrieval layer. So data layer means whether the data is correctly given or not, whether the checking strategy is chosen, whether embedded. So like that, it has individual criteria. Then retrieval layer, whether it was properly retrieved, then whether it was ranked properly, and if it is not reaching the expected outcome, then whether re-ranking was applied or not, and was there any transformation in the pipeline, was there any metadata being used. So like that, each and every issue is being clearly provided in the checklist. Okay, then agent layer, then evaluation layer, and finally the production layer. So in these 5 layers, you go for the design pattern series. Okay, design patterns are nothing but the final outcome. Now, based on this design patterns checklist only, the data analyst will choose the coding mechanisms. Then evaluation and metrics. So why RAG evaluation is critical? See, the main involvement of RAG along with LLM was to go for validation. Okay, and without having a proper validation, then you can't give a justification to RAG systems first of all. Okay, so compulsory there is an evaluation which is the critical for RAG. So generally, RAG systems will fall under 2 categories: a bad retrieval and a bad generation. Okay, because focus is more on the retrieval and the generation, which is the final stage. Production layer is called the generation. Okay, so the evaluation challenges are whether retrieval failures are silent, whether generation failures are silent, focusing on both. Then again, whether component interactions are complex and ground truth is expensive. Okay. So like this, we will be going for evaluation, measure, analyze, hypothesize, improve, and measure. And the key principle is evaluate at the component level, not at the system level. Okay. Then finally, when it is coming for an integration, then go for a system level. So that is what I told you. Even in the previous slides, when I was focusing on the testing part, then I told you don't go till the final stage. At each and every stage also you can go for a testing, because if there is some error at the initial stage, that error will be continued and reaching the final stage where the output will be totally a disaster. So better cut short errors at the entry level itself, component level itself. So this is the RAG evaluation framework. So first focusing on the user experience, then retrieval component, then generation component, and finally assessing the end-to-end performance. Okay. So you can also correlate the same thing with analysis, design, coding, testing cycle. Okay, where feedback can be taken at every level, which gave rise from the moves the SDLC models from waterfall model to incremental model. So in incremental, you'll be taking evaluation at every stage. Okay, like you have prototype model, you have spiral model, win-win spiral model. So all these are the variations of the iterative models. Then retrieval metrics, you can have a recall, precision. Okay, you have MRR, mean reciprocal rank, and then NDCG, normalized discounted cumulative gain. So you have formulas for all these. So based on that formula, you will be going for. So generally, target will be 0.8, 0.8. Almost you can take a standard of 0.8. So 80% of value is received, then you can say that it is a good, because already bad retrieval and bad generation. Okay, so if it is more than 80%, then you can call it as good retrieval and good generation. Now in generation also you can see 0.8, 0.85, 0.9, 0.9. So here also more or less on an average you can take 0.8. Okay, so faithfulness, answer relevance, answer correctness, answer similarity. Then you have Raga's framework. Okay, so here you can see when you go for the comparison of all the frameworks, Raga framework is focusing on 7+ different RAG specific metrics. Okay, and out of all these criteria, like the Raga deep evaluation, ML flow, LLM evaluation, RIs, Lang Smith, and prompt flow, Ragas is now initiated. Then later we are moving toward deep evaluation where it is having 15 plus, including the hallucination. So hallucination is also considered as one of the metrics. Okay, but as of now, we are, research is moving more towards comprehensive RAG evaluation. Then building the evaluation data sets. So even whenever you are going for different knowledge-based construction, we also ensure that the data set is also to be improved on a regular basis. Say for example, initially I start with an evaluation, or I start with model construction with 100 records. But later, when I keep on getting some records, now after performing the model construction and model usage, you ensure that that particular new record, after validation, it is to be added or appended to the given data set so that the data set size increases. So when the data set size increases, obviously there's a high scope for learning. Then when learning is improved, then obviously there is a high scope for increasing your productivity as well. Okay, whether it is accuracy or any metric increases with respect to the size of the data set. The more the data size, the more is the productivity of any particular model. Okay. So their data set composition is 40%. If it is 40%, then direct to look up from single document. If it is a medium, then requires synthesis across 2 to 3 documents. If it is hard, multi-hop is obviously required because it is complex. Okay. And when it is advisable, then we go for trick questions or ambiguous queries. So these are edge cases which you called as abnormal cases. Okay, so for that we call it as critical cases. For this you go for multi-rack architecture again. So this is also a part of testing and continuous evaluation. And these are the best practices of evaluation. Evaluate components separately, as I told you, so which is also called unit testing. Then use multiple metrics. So single metrics is not good to use. So only if I focus on accuracy and leaving all the other aside, it is not good enough. Okay, so focus on multiple metrics. Then test edge cases. So just now the last one discussed, because anyway all the remaining will work well. So focus only on the edge case, and that is the reason whenever a researcher, he focuses more on a true negative and false negatives. He don't focus on the true positives and false positives. Because once that negative can be turned up to positives, then obviously the accuracy increases. Okay, so focus more on the edge cases. Then measure cost and latency, involve domain experts. So when someone is working on a particular application area, make sure that he is having a full knowledge on that domain. See, I may be an engineering from the engineering background. I am from the MPC background. I have done my BTech, I have done my MTech, I have done my PhD. But during my BTech, I have done in DRDL. Okay, it's their own project. But during my PG and PhD, I was focusing on the disease prediction, which was completely a biological background. So what I have done, I have focused on the attributes which are relevant to that. So first a rigorous study was done on that particular domain area. Then I started my research. Okay. Even now I can list out. The main focus will be on the age, gender, CP, which is a chest pain type, cholesterol, angina, okay, talach, tal. So these are some of the attributes which are important for ECG, one among which is ECG. Okay, so these are the more important attributes for a heart disease prediction. So just like that, because I can't say that I am from the MPC, I am not from the BPC background and I don't know about this. So it is your responsibility to learn that particular domain area and then work on with respect to the technology. And then document everything. Now there's the most important, foremost important, each and every aspect, whatever you are doing must be documented. Without any documentation, nothing is, because even what RIG says, what RAG tells, validation. Now, whatever work you are doing, until and unless you document it, it is been not validated. Okay, clear? And then production and deployment, which is the final. So focusing on the various metrics, we'll be focusing on the scaling strategies. We'll be focusing on the checklist again, production deployment checklist. And once this checklist is being met, then you can release the product into the market, or you can hand over the product to that particular person, the end user. Okay. So the future trends of RAG is focusing on multimodal RAG, focusing on the text, images, video and audio, then agentic autonomy levels. So focusing on, like you can see, the automated cars. Okay. And then smaller and efficient models, which will be at the corporate level, small scale and middle scale level. Then knowledge graph integration, so which is focusing on the explainability and traceability. So explainable AI is coming under this knowledge graph integration. And then federated RAG, which is focusing on a distributed knowledge across organizations. So which is nothing from multiple organizations or cross organizations. See, you can have a third party vendor giving a service to two other vendors. Okay. So correlating these three people, there must be a RAG, which is called a federated RAG. So this is the future of the agentic RAG, which is expected to be for the next 2 years. Okay, 26 to 28. So this is the summary and key takeaways. We have focused on the agentic RAG, designing knowledge-driven autonomous AI systems, where we focused on the multi-agent systems, land graph, evaluation, design, cost optimization, security and compliance. Okay. And obviously, people say that AI has come into the picture, ML has come into the picture, now RAG has come into the picture. So obviously, the jobs will come down. Absolutely no. Because of these inclusion, the jobs are still increasing. Okay, but only thing, the knowledgeable persons will get the jobs. Okay, the persons who are having a knowledge on these areas, AI, ML, and RAG, will obviously be the persons to get selected. Okay, so focus more on the new areas, the technological developments, and be upgraded. And as a part of faculty fraternity, it is our responsibility to go for a lifelong learning. So that is what is expected from the management and even for ourselves. Okay, so thank you all. Any queries? I think I am within the deadline. 2 minutes left out, because I was instructed by the organizers, sir, within the first half you covered only 25 of your slides. Then I told the starting slides are introductory, so I need to take more time. The next upcoming slides are almost repetition, but in a different perspective. So it's not a redundancy, but in a different perspective. So I have skipped the slides. Anyhow, I'll be forwarding my slides to the coordinator, and I hope the coordinator can pass on the slides to the audience, so that I expect people to come up with more research. I'll also give you my contact details so that you can communicate accordingly. Thank you. Thank you all. Any queries? Any queries, audience? Hope I am audible and visible to you all throughout the session.
Yes.
Yes.
Yes, sir.
Any queries? Yes. No queries. So can I assume that everyone understood all my explanation clearly? See, of course, I can understand that online sessions are always challenging. That's the reason I kept my video on for the entire session, and was expecting to keep your videos also on for the entire session, so that we can feel that we are in a physical setup. Okay. And I do understand that session after lunch is also challenging, but I feel that I have done my best in giving the maximum content within the stipulated time. So if time permits, I'll also plan to have a visit to your organization. So once again, I thank you, the management, the HOD, the faculty members, all the audience over here for giving me this opportunity and having for the patience listening. So any queries, please feel free to communicate to the coordinator so that the coordinator can post to me. Or if you still have a chance, you can ask here.
Thank you very much, sir,
Okay, thank you.
for the insightful and informative session.
Okay.
Your presentation on agentic RAG and knowledge-driven autonomous AI systems has given us a deeper understanding of how advanced AI systems can combine knowledge, retrieval, reasoning, and autonomous decision making to solve real-world problems.
Yes,
On
exactly.
behalf of the organizing committee and all the participants, I express our sincere gratitude for your valuable time and expertise, sir.
Thank you, Kasim.
I
And have a
also
happy
thank,
learning. Yes, madam. Yes.
yes, sir, please.
Have a happy learning, all the audience. And before the session is wind up, I expect all the participants to turn on your videos, because I do have a habit whenever I take an online session uh, to have a pic of all the audience, whoever there on my screen at least. If you want, I can read out the names. Madam, with your permission, can I read out the names? Thank you, madam. Then Naga Prasad Rao sir, Bhagya Lakshmi madam, Manoj sir, Roy, Dr. MS Roy sir, Sheikh Mohammed Shakir sir, Vasanti madam, Soumya madam. If you all can turn on your videos, I think even the coordinator also will be happy in taking a pic and filing them for your other purposes, accreditation purposes. Manoj sir, you can continue with your video on.
Sir.
Can I expect any more on my screen?
Pavani, ma'am.
I hope Pavani madam is also there in the session, but is not on my screen. Okay, I can see inside my screen. Okay. Okay, madam, you can conclude with your valedictory speech now.
I also thank all the participants for their active participation and enthusiasm throughout the 2 days session. Tomorrow we look forward to 2 exciting sessions. Dr. S. Vasvi, Professor with VIT-AP on the role of AI in modern space missions, and Mr. Prithvi Narayana, Data and AI Engineer, TCS Hyderabad, on building real-world AI-driven workflows with the N8N automation tool. Thank you all. Have a pleasant evening and see you tomorrow.
Thank you all for patient listening. Thank you, madam. Thank you.
Thank you.